All right, guys, let's go ahead and do these problems. Okay, again, we're dealing with end behavior, so I'm gonna put the template up here of how we write down end behavior. So this is how you should always start end behavior. Okay, so that is there. Our job is to fill in this box. And then we have f of x with an arrow, and then we're going to fill in this box. Okay, so we're going to have two of these lines exactly the same. X, fill in the box, and then f of x, fill in the box. Okay, so we'll start with number 13. All right, so this is how I like to fill in these boxes here. The first box is, think of it this way. How far to the right does my graph go? Okay, so let's look at our graph here. I know it's a little funky graph, but I'm gonna clean it up a little bit. We'll put some arrows on it. So arrow, arrow, so it looks something like that. Okay, here's the thing. Again, this is not much math, it's just a lot of understanding here. We wanna know, to fill in this box, looking at the x line, that's why we have an x here. Okay, looking at the x-axis, how far to the right will my graph go on the x? Does it stop at 1, 2, 3, 4, 5, 6, 7? Does my graph stop on one of these dashes? Okay, again, these dashes are numbers. There's 1, 2, 3, 4. So we want to use these dashes to let everybody know how far to the right is my graph going. Okay, so if you look, because this is an arrow, I want you to imagine that this graph is going to continue to do this until it gets forever and ever. It's just going to keep going down like this. Okay, but it's not only going down, it's also going to the right. So it's going to keep going to the right as well. So because of this arrow, this graph will not stop going down, and it will not stop going to the right. It goes at this angle like this, which tells us our graph never stops going in this direction. Okay, I know it looks like it's going down, but it's also going to the right, and it will never stop at any one of these marks. Okay, so at number 1, it doesn't stop. It passes number 1. Number 2, it passes. Number 3, it passes. The number 1,000, believe it or not, this will eventually pass the number 1,000 on my x-axis. The number 1,000,000, it will pass. The only time when we have this arrow here that goes not straight down, but it's actually going at an angle, that means our graph, as it goes to the right, will go all the way to, this is the positive side, so it's always going to go to positive infinity as it goes to the right. So anytime you see an arrow, okay, more than likely is going to go to the right to positive infinity. Later on, we're going to talk about when these things stop. We actually have to put a number, okay? But for now, this guy's going to positive infinity. So how far to the right does he go? Positive infinity. Okay? So now that we were talking about how far to the right, on that side, so as he goes to the right, as he moves this way, is he going up or down? And this is what we're going to fill in here. As the graph moves right, are we basically asking, how far up or down does our graph go? Okay, and that's what we're going to fill in here. So as we go on the right side, because we're dealing with the right side, as we go in this direction, as our graph goes in this direction, is it going up or down? And the answer is easy. We are going down. But what we have to answer is, how far down is my graph going? Is it stopping at 1? Now we're using this line to measure. 2, 3, 4. Because of the arrow, this is a little easier to see that my graph is just going to continue to go down forever and ever. That means nothing is stopping it. So eventually, it's going to go down to negative infinity. Okay, so I'm putting negative infinity here. All right, so now we know that is how far to the right. So this one is, we'll use this to represent how far to the left does my graph go. Okay, so now we're looking at the left side of my graph. Again, we have an arrow. So imagine this arrow is just going to keep going in this direction forever and ever. So what we want to understand is how far to the right, using the x-axis again, how far to the left does my graph go? Does it stop at any one of these marks? Okay, because of the arrow, my graph does this. It just keeps going and going in this direction, up and left. So that means this graph will never stop going to the left either. It's going to continue to go to the left forever and ever. And when that happens, it goes all the way to what we call negative infinity. All right, so that means our graph is going to negative infinity. Okay, so how do we fill out the last box? Same idea. As the graph moves left, how far up or down does my graph go? Okay, so now we're asking the same question, but now on the left side. So if you look on the left side, my graph is going up. Okay, it's going up. And because of this arrow, that tells me it's never going to stop going up. It's going to go up forever and ever until it reaches, and when it's going up, it's positive infinity. Okay, and that's how we do the end behavior. We got to answer those questions, and we should be able to fill in those blanks. All right. So number 14, we do not have a graph, but we can figure out the graph by using the rules that we talked about last Zoom. If you don't remember the rules, check out the rules last Zoom. So for number 14, we look at leading coefficient. Okay, what's the number in front of the highest powered x? Well, we only have one x. So the number in front is -8. And all we care for in leading coefficient is it positive or negative? So we have a negative, and the negative tells us that on the right side of our graph is going to be going down. Okay? So if I was graphing this or sketching the graph, on the right side, our graph is going like this, down and to the right, on the right side. On how do you figure out the left side? We look for degree. So the degree is the highest powered variable in standard form. So this is standard form. What's the highest powered variable? What's the exponent here? And that exponent is 1. So when we talk about degree, all we care is about odd or even. Since this is odd, the rule is when you have an odd degree, it does the opposite of what your right side does. So if my right side is going down, odd means we're going to do the left side in the opposite direction. So that means our left side is going up because it does the opposite of what our right side is doing. So my graph will do this on the left side. Okay, so now that we have what our graph is doing at the ends, we can then ask these questions again. Okay, so let's fill in these blanks again. All right, so I'm gonna use the same template. So let's fill this in. So erase this bad boy here. And let's fill this in. Okay, so based on this sketch now that we got from this equation, how far to the right does my graph go? So looking at the x-axis, how far does my graph go in this direction? Well, because of the arrow, it's going to keep going down and to the right. And it's going to go forever and ever. So that tells me it's going to the right until it reaches positive infinity. Again, there's positive infinity. It's all the way at the end, okay? And I know it's going that way because of my arrow. My arrow says I'm going in this direction forever and ever, which means eventually I will never stop going to the right. Okay? So there's nothing stopping me going to the right. Now, the next question is, as I go to the right, is my graph going up or down? So basically on the right side, is it going up or down? It's easy to see I'm going down, and I'm going down because of the arrow forever and ever. And what's down forever and ever? Well, when you talk about down forever and ever, that's negative infinity. And again, we're using this line to measure. Does it ever stop anywhere on this line? Nope, it goes down forever and ever. So that's going to be negative infinity there. Okay. Once we're done with the right side, we go to the left side. How far to the left on the x-axis will my graph go? Since it has an arrow, it's going to go to the left forever and ever. So the left side of the x-axis is called negative infinity. It will go to negative infinity because it never stops going left. And then is it going up or down on the left side? It's going up. And how does it ever stop going up? And the answer is no. It goes up forever and ever, so that's positive infinity. Okay, so that's end behavior again. If you'll notice, it was exactly the same thing because they both, if you look, they both have the same end behavior. On the right, we're going down. On the left, we're going up, and they have arrows. Okay, let's go ahead and do 15. This one is in factored form. So when we have an equation in factored form with parentheses like we do here, notice this one didn't have any parentheses. Okay, that was standard form. When it's factored form, it changes slightly, okay? We still start with leading coefficient. So what's my leading coefficient? So let's look in front, okay? This is the highest powered guy, or your leading coefficient in factored form will always be in the front. So what's the sign? Is he positive or negative? So my leading coefficient is negative. And since it's negative, what does that tell us about the right side? It tells us the right side is going down. Okay, I'm going to sketch a little graph here. My right side is doing this again. All right, so now to find out the left side, we need the degree. So we're thinking of odd or even. So this is where factor form changes a little bit. Since it's factor form, we have to add all the powers, all the exponents together. And every parentheses and every term has their own power. So for example, this guy has a power of 2. This factor, so every factor has its own power, has a power of 1. And this factor has a power of 1. Okay, so now all we have to do is add up those powers. 2 plus 1 plus 1. So my degree is actually 2, 3, 4. So in this case, my degree is 4. So we don't care about the number right now. All we care about is it odd or even. So in this case, it's going to be even, which means my left side does exactly, when it's even, it matches what my right side is doing. Even means matching. So that means my left side is also going down. Okay, because it will match my right side. All the rules are in the last zoom, so check them out. So that means my left side has to do that. Okay, so let's fill in this stuff. Okay, so let's start again. How far to the right is my graph going? So if you look, how far to the right does this thing go? Is going down and to the right forever. So as far as the right side, it will go to the right forever. That's, hopefully you know now, is positive infinity. Okay, because positive infinity is here, just like on this graph. This graph, these positive and negative infinities never change. They're always, these are their locations. So right is positive infinity. As I go to the right, is my graph going up or down? So it's going down. Now we're using this line to measure how far down does it go on this line. Because of the arrow, it goes down forever and ever. And when we go down the y line, it's negative infinity. Okay? So now we look to the left side. How far to the left does my graph go? Since it's, again, an arrow, that's going to go to the left forever and ever. On the left side, we call that negative infinity. So on the left side, how far up or down is it going? So we know it's going down, and it's not going to stop going down. And it's going to go down to negative infinity. Okay, so again, if you go to infinities, this is the positive side. So this is positive infinity. The left side would be, if it goes forever, is negative infinity. Now looking at up and down. Up, if it goes up forever, that's positive infinity. If it goes down forever, that would be negative infinity. Okay? Okay, let's go through these real quick. We're going to give the end behavior of the following function. So basically what we did, again, this is in standard form, so we are not adding for the degrees. The only time we add for degrees is when it's in factors form. So notice the difference, okay? So let's get this done real quick. We're gonna go a little faster. Here's my leading coefficient is gonna be positive. That means, I'll do a little sketch. Since my leading coefficient is positive, the right side goes up. Okay, my degree is even, because now in standard form, I only look at the highest power degree, which is 4. That's even. That tells me my left side's gonna match my right side. So it's also going up. Okay, so let's write this out. I'm gonna write a little faster. So what's happening on my right side? My graph is going to the right forever and ever. That's positive infinity. As it goes to the right side, is it going up or down? It's going up, and it's going up forever and ever to positive infinity. Okay, now it's asked the same. How far to the left does my graph go? So how far to the left? Since this arrow is going left forever and ever, it's going this direction forever and ever. That is the negative infinity direction. On the left side, is it going up or down? It's going up. And how far up does it go? When it's going up and it never stops, it goes to the positive infinity direction. Okay? So we're done with A. B, leading coefficient. Let's check this out. Okay, this is factors form, so your leading coefficient is just going to be in front. It's going to be negative. So my leading coefficient is negative. What does that mean for my graph? It means my right side is going down. My degree, now this is where we add the degree. So we're not adding this guy's power because he does not have a variable. Only the parentheses or coefficients with variables. So we have 12 plus 13. That gives me a degree of 25, which means we are having odd. Okay, odd means we do the opposite of the right side on the left side. So that means this guy's going up on the left side. So let's write this in. How far to the right does my graph go? So if you look, since this is an arrow, it's going to go to the right forever and ever. Okay, slanted to the right. So that's going to the right, positive infinity. As it goes to the right, how far up or down does it go? So my graph is going down on the right side, and it's going to go down forever and ever. That means it's going down to negative infinity. Okay, do the same thing for the left. How far to the left do I go? It's going to go to the left forever and ever. On the left side, that's called negative infinity. And is my graph on the left going up or down? My graph is going up on the left side, and because of the arrow, it just keeps going up, which means it's going up to positive infinity. All right, let's go ahead, and these are a little bit different. Number 2, we're going to have to write in our polynomial, okay? So let's look at the rules. The left and right end behavior is the same. So what does this tell us? When the left and right are the same, okay, that tells us our degree is even. Okay, if you look at the rules I gave you last Zoom, when your left and right end behavior do the same thing, that means we have to have an even degree, or our powers are even. Okay, the leading coefficient is negative. So my leading coefficient is negative, so whatever number I put in front has to have a negative number, and the degree is greater than 6. So my power has to be even but bigger than 6. So let's go ahead and do this. So again, your function, if you did this function on your own and you understood it, it might look a little different than mine. So we're going to just take these rules into effect. Okay, so the first thing I want to put in is my, well, we'll put it this way, leading coefficient. And we know my leading coefficient has to be negative. So I'm going to put negative. All right, and it doesn't say what kind of number. We could put -1, -2. I'm going to put -3. All right, just because. You could put -100 if you want. Then my end behavior has to be the same. Okay, so I'm going to put this in standard form because I think that's easier for me. Which means my highest degree has to be even. So my highest degree has to be even, but it has to be bigger than 6. So I'm just going to put the next even number bigger than 6. 8. Okay? And we actually can stop there if you'd like. Or if you want to get fancy, you could do, okay, I could add in x to the third plus 2x squared. You could do something like that, all right? But in essence, all you really needed was that. That is the correct function. And if you wanted to get fancy, you can add in other variables at the end. Okay, so it satisfies negative leading coefficient, even power, because of this information here. So even power. And our highest power has to be greater than 6, but it still had to be even. All right, let's check this out. the left and right end behavior is opposite. Okay, that tells me my degree is odd. Okay, the leading coefficient is negative, so my LC is negative. And the right end is decreasing. So the right end behavior is decreasing. So we got odd, so, and then we know the right end is going down. Okay? Because the right end is going down, what controls the right going up or down? It's actually the leading coefficient, which means our leading coefficient better be negative. So in essence, this here, the right end behavior is decreasing or going down. It's basically telling us the same thing. Your leading coefficient better be negative. Okay? So, leading coefficient, again, we'll put that in first. Needs to be negative, so we'll do -2. X, and my degree needs to be odd. So my highest power here needs to be odd. We'll do the 3 as odd. And then we'll make it fancy. I'll do 7x squared. We'll make this a little fancier. But again, once you did this part, you're done. You could add all this fancy stuff later if you'd like. Minus 4x plus 2. Okay? All right. And that's how we do that. Okay, so let's, I'm just going to give you the answers to these really quick and see if you understand how these bad boys work. All right, start with this first function. So I'm going to sketch what the function should look like. So the leading coefficient here is positive. Okay, so that means, let's do a little bit bigger. That means my right side's going up. Okay. It's odd. That means my degree is odd. That means my left side does the opposite. So that means my left side's going down. Let me clean this up a little bit. And here's the kicker. We got a lot of functions that do that. So how do you distinguish between them? Well, there's one more piece of information that you need to know. Okay. And it's this idea. So we got that. So we know the right side's going up, the left side's going down because of our leading coefficient's positive for the right side. Our degree is odd, so that means our left side does the opposite. Okay? But your constant, the guy without the variable at the end, this guy is always your y-intercept. Okay? And if you've forgotten, your y-intercept is where does my graph cross the y-axis. So if I had to sketch this guy really quick, we're crossing the y-axis at 2. So it should look something like that, where we cross at 2. So what graph looks like that shape, but crosses at 2? And if you look, we have B. So this first guy is B. All right. Same thing here. Leading coefficient is positive. So that means my right side's going up. My degree is odd. That means my left side does the opposite of my right side. So it's going down. And my constant, which is the guy without the variable, since it's not there, it's really 0. So that means my y-intercept is 0. So that means I'm going to do that. It goes right through the 0 line. Which one's doing that? It's R. Okay. So let's go here. Leading coefficient, positive. So that means my right side is going up. And my degree is even, so my left side is going to do the same. It's going to go up And my constant is not there, but when it's not there, it's 0. So my y-intercept is 0. Okay, so we're looking which one has both going up, but a y-intercept of 0. It's like that. Okay, so that's going to be u. Okay, so here, leading coefficient, what's the number in front? It's 1. So that means it's positive. So let's sketch this. So my right side is going up because it's positive. My degree is odd. That means my left side is negative. Okay, let me make this a little bit better. Negative. And then my leading coefficient is -8. I'm sorry, not my constant is -8. So that means my y-intercept is -8. So that means it's way down here. It's going to do something like that. Okay, so if you look, that is S. Again, y-intercept is where does it cross the y-axis, the vertical axis. Okay, I know you could pretty much figure out the last one here, but we'll just do it. My leading coefficient is positive, so again, right side is going up. I have even. That means my left side matches, it's the same. And I had a y-intercept or constant. So it crosses the y-axis at +2. So it's going to do something like that. Okay, so which one is that? I know my sketch doesn't look like it, but it's there. Going up on the left, going up on the right, and it crosses the y-intercept at 2. So this is T. Okay, hopefully this stuff helps, and we'll go from there. All right, guys, I'll get you the checking code and get you out of here. If you have any questions, stay on.